What's going on, everybody? Here with another quick-ish AI query use case, but it's actually two use cases rolled into one. So I'll actually explain why in a moment, but breaking down the two use cases. So the first one I got asked was more from a hygiene and compliance perspective, and that was how do we audit for actual backups within our environment, especially our critical systems, to ensure that we have proper backup and logging. And then the second use case was actually this IOC that I was given, which was using WB admin to go ahead and dump credentials of domain controllers from a potentially malicious capacity, aka not a routine backup. But the reason that I combine the two is because they're effectively the same concept, right? Nobody knows your environment better than you do. And looking at what is normal behavior and abnormal behavior is how you determine what is malicious versus what is just a standard good hygiene backup job, right? There are some other patterns you could look for, but again, in general, it's that delineation. And in order to make that delineation, you need context. And that's where AI Query excels, is in providing that context and then allowing you as the admin to make that determination, because no amount of AI and nobody else knows your environment better than you do. So breaking this down, and with one huge unfortunate caveat, I do not, my device that I was testing this on is not a domain controller, so I didn't do the NTDS portion, but the actual IOC should look the same anyway. So with that said, I did do dumping of the system in security hives, but if we're looking for the actual IOCs, which I'll showcase what we see in the actual tool itself in a moment, but breaking down the IOCs we're looking for, we have the actual command itself, WB admin, and then we can see the backup target and what it's actually including. And then right here, we can see the backup target as the local loopback over SMB with admin share, potentially easy staging or early easy staging, what have you. The example output, artifacts on disk from the completed backup, so the actual components that were backed up themselves, and then any copies to a mount, as well as correlation with Windows backup logs. So now that we have those indicators, let's go ahead and check out how AI Query would help you detect this, whether it is normal or abnormal. And that depends on your own environment. So what I went ahead and did, so this wasn't a crazy long video, it'll probably be long anyway because I talk a lot, but I went ahead and I created a query pack using, all these were created with AI, with our AI Query Smith. And what I actually did is I combined them all into a query pack, which if you're not familiar is, I like to think of them as a thematically correlated sets of queries that kind of each individually give pieces of a puzzle and together paint a full picture, right? So we don't need to go through all of these, and I actually already ran this, but we see that we're looking for backup jobs via the Windows event log tracking. We're looking for registry changes via VSS diag events. We're looking for sysmon registry events, and then we're actually looking for those artifacts on disks right there with the actual backup XML files and the disk image. That could be combined in one, but I like separating them out. And then once again, sysmon looking for process events. So if you have not watched our prior video, I highly recommend you do so. Effectively, I break down why sysmon works so well with AI Query, because effectively, AI Query is phenomenal at harvesting stateful information. Think of it as snapshots in your environment, which is very useful for things like persistence mechanisms, configuration monitoring, application logging, things like that. But it's not it's not process centric. It's meant to be used in tandem with a process centric tool. And sysmon gathers process centric information, dumps it to the Windows event log, so that AI Query can go ahead and actually extract the information and only the vital bits of information as needed, both saving you, gathering complete visibility, and saving you time and money if you are actually dumping it to a SIM. So you're not parsing through potentially useless logs, and you're not potentially incurring the cost of sending, excessive logging information. As you know, you can always go back and extract and enrich as needed. So they work phenomenally together, and this is yet another breakdown of showing exactly how. So as mentioned, I already ran these. I could go through the actual SQL associated with each of these, but they are quite beefy queries, hence why I needed AI to help me write this, because look at this thing. This is a monster. I wouldn't be able to write this myself. It is well formatted with the breaks, but just not in this little view. But what we can do is we can actually check out the results that I just recently ran. And so if we're looking at each of these, let's start without the sysmon stuff in case you don't have that. What can we see otherwise with just AI Query? Well, boom, we have the Windows event log event right here, and we can see it looks for multiple different event IDs. If we actually check out briefly in the query, we can see it has a case statement looking for 1, 4, 5, and 14, which is started, success, failure, and completion. And so here we can see that it started, there was success, and then it completed. So we get a whole bunch of information here. If we wanted to go through them, I won't go through all of it, but we do see that backup target, that local loopback over SMB right there. And then we can actually see the volumes information if we were interested. And then one thing that I thought was kind of interesting is you see the start time and the end time of the actual initial portion of the backup. And we can see it's 9/23/02/38 to 9:23:02:47. So it took roughly 9 seconds. So other events we're looking for are around that time frame. And again, there's additional information we can go through if we wanted to, but not overly critical at this point in time. Now we've confirmed, hey, there was a backup on 2/9 at 23:02, and that it started, it was successful, and it completed, and that's the information to confirm the backup process. So again, maybe that's normal if you have it expected to run at those times or on a set job. But what you can also correlate is you can correlate some registry information to actually show the aligning there. But as we talked about with the article in the IOC, let's look for the artifacts on disk of the backup itself. And that's where we're looking for something like the disk image, right? I just broke it out separately. We can see the actual size in kilobytes that was converted, when it was last edited or written to. And then we can see that it aligns 9:23:02:54. So basically, right after the actual backup was created, it then took a few seconds to write. And where that exists in case we wanted to go ahead and move it, delete it, what have you, as well as the file name. Same exact things exist for the actual XML files. I just broke them out separately since XML versus the actual disk image itself, as we can see, very much smaller sizes in general. But if we wanted to, we can actually, view some of these, cat these out, and if we wanted to get crazy with it, we could actually create a custom extension that could parse this information. But we have the hash, we have where it was written to, and we actually have the timestamp. So we've confirmed both a backup job occurred via the event log. And then we also confirm the artifacts that are written to disk. So again, identifies whether it's potentially normal or not. We have registry events that Sysmon was gathering. So this is actually the registry information itself. And then the events are within here. And so what we can do is we can flip it and look at time. But one thing I like to do, because again, we're trying to determine whether this is normal or expected. And oftentimes, if you're having backup jobs, you're probably having them run via something like a scheduled task. And we can actually gather the scheduled tasks. I didn't in here since I did this one manually, but we could go ahead, we could say user not contains, and then we can say system. And so basically, let's just say anything that isn't automated, that isn't system, that is kind of more user attributed. And we can see here we have administrator with the process go with the timestamp that correlates almost exactly to what we were seeing. We can also see the actual target object in the registry hive. And then what we can see too is that this Swift on security, which again, I broke down the last Sysmon video, or the last video we had talking about AI query and Sysmon. We have a rule name, which we could go ahead and we can correlate to actual MITRE if we're interested and why it could be potentially suspicious. But so again, more pieces of information to help paint that full picture of, is this normal in my environment or is this an attacker? And then kind of the final piece of the puzzle is actually seeing the command information itself, because again, AI query point in time stateful snapshots of your environment. So you may not see process command lines unless you're taking a snapshot at the right time or it's being logged somewhere. But that's where Sysmon becomes wildly helpful, because it's constantly gathering that information and logging into the Windows event log, which we can then extract as needed. And we have this big, long, beautiful query here. If we actually look at it, it's a decent amount of items, but what we're really looking for is we're seeing right here the file name WB admin, we're seeing the user of administrator, and then we're actually seeing the command line right there, which is the exact IOC of the command being passed with the specified backup target and what it's including, and it's being run as quiet. So maybe that's abnormal. Maybe the admin shouldn't be doing this. Maybe, unfortunately, this admin user is compromised and we need to investigate further if this is indeed abnormal. And the last piece we can actually see if we scroll on over is we can see the parent command line. So we can see it's by PowerShell. So effectively, PowerShell was executing this command on that device, which again, leave to you to interpret whether that's normal or not, but pretty clear assumption that it's not normal. And that's kind of the full use case in video, where we can see the artifacts to both audit and confirm legitimate backup jobs, and also identify deviations from what we believe is normal and legitimate to say, hey, this may be an attacker trying to actually harvest credentials. Okay, so the reason for the abnormal cut is I actually keep going for another like 5 to 10 minutes talking about a cool pro tip that I actually want to showcase, but I can save that for another video. I realize this is getting long already, but that's the whole video, identifying actual stateful information in conjunction with Sysmon to identify what is and is not normal in your environment as it pertains to Windows backups. And then from there, actually being able to correlate that information and say, hey, this is something we need to look into further, or nope, normal, we're good, we're actually meeting any sort of compliance or security internal requirements. So hopefully that was helpful. If you have any other use cases, please, please, please let me know. I love doing this. I'll straight up tell you if we're not able to do it, but if we potentially are, I will spend tons of time figuring out exactly how. So please share anything with me. And until next time, please check out our videos on YouTube and LinkedIn, and check you all later. See ya.